Here we go. Just do one through.
Okay, some of them are self-explanatory though.
Yeah, some of them
Like
are.
6.
There's so much Madison, you are also close again. You don't want to.
I don't know why you and Connor can't sit in proximity with each other, but it seems not to be a good thing. I don't blame you, Connor. No, it wasn't you blame me.
Number 1, children. I guess if we're going to do most of them, you should have labeled your picture frame as x plus 3 times x minus 3, right?
Right.
And if it's finding the area of that photograph, you just multiply them together. Seems like it's been a while since we did this, but this is FOIL first, outside, inside, last, right?
Yes.
And the first 2 terms, oh, we should write it out. FOIL, first 2 terms is x squared, correct?
Yes.
The outside term, negative 3 times x is negative 3x. Inside term is plus 3x. And the 2 last terms multiplied together is a negative 9. And these are opposite terms, that's why they drop out. And you're just left with x squared minus 9 for your answer. Technically it's inches squared, but that's that. How many people got that correct? Close is always good in math. We like close. Won't get you any points, but. Oh, well, what was so hard about this? Use the y-intercept in your comparison. I don't even know what that means. This just is trying to get you to see this. If you just have f of x equals x, remember I said just think about that as being y equals x. That just means whatever x is, y is. You get this graph. Right? Through the origin, goes up 1 over 1. The only thing that changes, since the slope is the same, is where it crosses the y-axis. It simply means you are going to get the same exact line, except it's going to be down here. Ooh. Up, down. Guess where x plus 6 would be? Up there. Where would be x minus 53? Down here. So your second line would be right there. As long as you have those 2 parallel lines, I think everybody's happy. Questions on that? How did I get which one? The first line?
Yes.
Right here. This graph is y equals x plus 0 if you like. There is the y-intercept. Good, John. The y-intercept is 0. It has a slope of 1 over 1, so it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. The second line, Connor, same exact slope, so it's going to be on the same slope, same angle, it's just going to cross the y-axis at a different point. If it was f of x is x plus 3, that means it would just be the same slope, but it would cross up here at 3. Same thing. You keep going forever.
So the second one you started down at negative 3?
What's that?
The second one you started down at negative 3?
Right, this one right here. Y-intercept is negative 3. It's just going to go up 1 over 1, up 1 over 1, up 1 over 1.
Alright.
And that was so.
Is the first line always going to start at the origin?
If there's no number after the x, that means it crosses y at the origin.
Okay.
I can't speak for what exactly the number is. Oh, Maya Clausing, why is the answer to number 3 Maya not 4?
I did not add the exponent.
Right.
I thought it was the highest one.
You just thought it was the highest number of the term?
Yeah,
No.
I just did.
You always, to find the degree of the term, you add all. Emphasize, Maya, all exponents. So it is 3, y has a 1 and 4, which is 8. No one should get that wrong tomorrow. Watch how fast that was. This one, who's this one? Who did this one? Jackson Roberts, this was you, right?
Yeah.
You told me the answer to this. Distributive property, again, you just multiply this term on the outside times everything. Negative times a positive is a negative, 3 times 2 is 6, a times a squared is a cubed. E has no friends. Negative 3 times 4 is a negative 12, sorry. AB squared. And negative times another positive is another negative. 3 times 3 is 9. A, B, C. I think my board needs some fixing here. Stop, did anybody have a problem with that? See this yellow stuff. Everybody good with that? Hip hip?
Hooray.
Hooray.
Oh, ooh, this was Emma Miller.
Yeah.
Do you see why there's a y squared on the bottom? Oh,
Yeah, I thought they crossed off.
well, not when you add fractions, you keep the denominators. 6x over y squared minus 8x over y squared. When you add fractions, you keep the denominators. Connor Morgan, right?
Yep.
Were you in that same boat? Did you leave the y squared off? And
Yeah.
then if you have 6x's and you take 8x's away from it, you're in the hole of 2x's. This isn't actually an easy test, don't you think?
No.
For sure.
Kind of.
For sure.
I do.
It's
I
easy
mean,
to
that
get
one on
notes.
purpose, and that one on-
I can't help you with number 6.
It's a single family, easiest question mark.
I mean, I can't, it's trial and error. Mr. Michelson, can you do cube roots out on paper? Do you know the method? There is some sort of a,
I don't know the method, but I just have certain ones memorized.
well, no, I was wondering, because I remember in school they talked about, you can't, there is some sort of a, what's the word? No,
Way.
back in 5th grade, it was like the first word they used. Algorithm. There is some sort of an algorithm to figuring out cube roots and square roots mathematically without doing it. Yeah. Otherwise, it's trial and error. But I told you, children, don't just wildly guess because you know certain things. Some number has to give you a 5 at the end. First of all, 125, to multiply a number together 3 times and get 125, it's not a very big number. Because if you start with 10 times 10 times 10, that's way too high because you're already at 1,000. So you know it has to be less than 10. So to try 15 would be goofy. Andrew, what did you try? 27? Did you? And it probably worked, did it? It's good because it ends in a 5, so 5 is a pretty good guess. 5 times 5 is 25, and 25 times 5 is 125. So again, this is not a division problem. Did anybody put 40 remainder 5? That's up.
I don't even remember
You
how
did
to
that as a division. If you thought this was division, 3 into 125. Oh, 7.
Dum, dum, dum.
7, now finally we get to something here. How about this? Did anybody do this? 6x's, well they should cross off. And 3 goes into 12 4 times. X squared over 4 is a logical answer.
I did that.
If you did that, Emma Miller. Why can't you do that, somebody?
Because you have to find the greatest common factor.
What? Because it doesn't work, did you say?
It doesn't always work.
No, it never works. I need a better answer. Remember, ladies and gentlemen, the only way you can cross things on top of fractions off of things on the bottom of fractions is if they are factors. If there's an addition sign in this, the only way this whole thing would cross off is if there was a 3x squared plus 6x on the bottom. If that was the case, then this whole thing could cross off with this, but you can't just pull pieces out of an addition part of a problem and say, oh, that crosses off with each other. For number 7 is, you jot your notes down, the only way this works is if you can find some common factors. In order to find if there's some factors, you have to, I'll get there, factor these things. What can I take out of 3x squared plus 6x? A, 3 and an x, correct? They both have those common factors. Reverse distributive property. What are you left with? If you take a 3x out of 3x squared, you have a x. Work with me here, plus
Yes.
what? Plus 2, right? Now, if you come up with a 3 or an x or this on the bottom, those will cross off with the top stuff. Will I? What can I take out of both of those?
6
A 6, and I'm left with an x
plus 2.
plus 2. Now, boys and girls, now you've got some factors to work with. You can get rid of this x plus 2 because it is the same as this x plus 2. This 6 can cross off with that because 3 goes into both of them. 2 and the x have to stay, so you're left with x over 2. Does that make any sense to anybody?
Yes.
Was that Cassie? Did you does that sound? Laura, does that make sense? Did you do that? So if you're
How did you get for the 3x, and then the x plus 2, how did you get the x for the x plus 2? On top.
here,
So,
so take a look here. I'm gonna rewrite it right here. This is what I started with.
Okay.
What do they have in common? What can you take out of both of them? They both, you can take a 3 out, and they both have an x. So I can take a 3x out. This is what I'm removing by dividing, I guess you could say.
okay.
So then you have to say, okay, what did I take out of this and what am I left with when I do? When I divide 3x squared by 3x, there's one x that's got to be left over because 3x times that gives me that x squared. Same thing here. If I take 3x out of 6x, if I divide a 3 into 6, I'm left with a 2. I already have the x there, so I don't need another x. Reverse distributive property.
Got it.
So far, so good, ladies and gentlemen. Ooh, I hate this one. Is that better?
Oh, a lot better.
Beautiful.
Should we just punt from there?
Yes.
It's like a snowfall. Who got this one right? Oh. Anderson, what did you do? Work with me here.
Well, I multiplied them by a negative 2 over b for each one, but a I'm not going to be involved.
No, I think you're right here. So you multiplied this times this. What do you get if you multiply an a to the negative 2 times an a?
A.
No, I do not.
Oh, wait a minute. A negative.
I get an a to the negative 1, right? Because this is a positive 1, negative 2 plus 1 is negative 1. And then I have a b there, and I have a b on the bottom, right? Oh wait, sorry. A b there, and then I have a b on the bottom that gets multiplied by the c to the negative 3, correct? That'll be there if you didn't catch. That's the first term. That's only half of it. Then you have to take that whole thing and multiply it by that second term over there. You have an a to the negative 2, which has no friends. A b to the third, and a c. I guess I'll do it in the order they do. And that's over a to the negative 3b. So far, so good? Stop me there if you don't catch that. Now you are not allowed, Andrew, to leave negative exponents in your answers. Fortunately for you, what's the fix, Andrew?
The negative ones to the top, there on the bottom.
Vice versa, yeah. So you're, well, first of all, we could cross off these b because they're alike. You are just going to flip-flop the places here because you're going to bring the c to the top to make it a positive exponent and the a to the bottom to make it a positive. Here, oh boy, this is going to get ugly. I can cross off one of these b's with the 3 up there and left with 2 b's, or not 2 b's, is it? Fish, is that the question?
To be or not to be?
Yes.
I think so.
Okay. And then I bring this a to the negative 3 to the top, it becomes a to the positive 3. Then I bring this a to the negative 2 to the bottom, it becomes a to the positive 2. What's going to happen to all those a's? Well, almost all of them, except for we have the one a left on top. And then don't forget that little c is hiding there. I don't know why he's there. So you're left with an a c b squared. And this is why, ladies and gentlemen, you don't do this on a little teeny tiny piece of paper because you can't possibly write all this stuff there. Was this the answer? C cubed over a plus ac b squared. ab c squared c. Yes, no, stop, hands up, thumbs down, 7 up. Ooh. Wait, there was somebody. I think we're making progress, children. Oh, what's the question on this? Determine which of the values below are part of the solution set of the inequality. Did I do that wrong, Fish?
No.
How do you do this, Caleb? Did you get it right?
I do not.
Who did get it right? Really? Only 3? Emily Vaught, how did you do it?
Instead of X, I just wrote down a couple of the numbers.
You had to write down all the numbers, or didn't you? Did you just decide after a while it was just gonna be right after that?
No, whatever is less than 9 is.
Alright, so did you take this -2 and put it in for X right there?
Yeah.
So you had 5, this 5 minus 2 times what this was, which was -2, was that less than 9? Did that work out? What is -2 times -2? Plus 4, right? And is 5 plus 4 less than 9? Is 9 less than 9? No. So this doesn't work, so you can't have that. But I think what Emily was saying, after that, she put 5 minus, put the -1 in for the X. And you got what? 5 plus 2, which is
Wait, what?
Sorry.
7. Is 7 less than 9? Yes, so this works. And you know these are just going to keep getting smaller numbers, so all of those work. Are you with me? Or do you want me to do 0? If I put 0 in there, watch how easy 0 is. 5 less than 9, yes. If I put 1 in there, 5 minus 2 is 3. Is 3 less than 9? Yes. If I put 2 in there, -2 times 2 is 4. 5 minus 4 less than 9, yes. So these are your numbers. Stop me there if Emily was too confusing. Just kidding. Oh, this one. What happened here? Madison, what did you do wrong?
I factored them all out, and then I don't know what I did.
Well, let's do that. What's the fact? 7 factors into just 7, right?
Yeah. And then 8 is 2 times 2 times 2.
8 is 2 times 2 times 2, and 10 is
2 times 5.
2 times 5. Now, what's the rule when you're finding least common multiple? You take the group that has the most.
Yes.
And did you?
Yeah.
Which one has the most 2's?
8.
So you take 3 2's. Which group has the most 5's? Which group has the most 7's? And you're saying when you multiplied all that, you got 140?
So now
Yeah, because this times this gives you 8. 8 times 5 is 40. 40 times that is 280. Anybody else want to share where they went wrong? Because a number of you said 140. Where'd you go wrong, Connor?
You know, I didn't even factor it. I wrote it all out. Like, all of them.
Wow.
And I
And
said
how
I
long
didn't,
would you say that took you?
you know, I didn't have the time to finish it. And I got to 140 and I'm
It's a
like,
lot of work.
alright, I just couldn't do that.
So Connor, after all that, would you say this is maybe an easier way to do it than you tried? Did we not go over this in class? I thought we did.
No, I didn't even think about that. I don't know, I'm just used to writing it out. And then, I don't know.
Ladies and gentlemen. This one was disappointing to me.
I got this one.
I don't know, it doesn't tell you, it didn't tell you what way to do it. Did you do it by graphing or did you do it by substitution?
I
Somebody?
did my substitution.
You did substitution? Who did graphing? Did you do graphing? Who did substitution? Who did graphing?
Wait,
Substitution, graphing, substitution. Those of you that are not raising your hands, how did you do it? Jackson?
Substitution.
Oh, I did it like a weird way.
Should we do an elimination just for fun?
Actually,
That's
I
I did it like where
Did
it
you
was
say?
like I did it weird.
Wait, for Zach, we're gonna do this elimination. Now remember with elimination, you want your X's and your Y's on the same side. So, Zachary, I'm gonna move this 4X to this side and get minus 4X. Can I do that? Plus the Y that was there equals the -1. Same thing here, I'm gonna move the 2X over there and get minus 2X plus Y equals positive 1. Did you get close to that, Zachary? And then to get them to be eliminated, I would just maybe multiply the bottom by a -1. Because I want my Y to be opposite of what it is. Is this gonna be something special or what? So So this becomes 2x, the y's go away, oh, I'm sorry, I should probably do it out, shouldn't I? Minus y equals negative 1. Now the y's cross off because a positive y and a negative y gives me that. Negative 4 plus 2 is negative 2x equals negative 2. Gosh, I hope x equals negative 1. Does it? Positive 1, sorry.
What did you multiply by?
I multiplied the bottoms all by negative 1s,
Okay.
and the y's went away. And if x equals 1, then y equals 3. But you didn't have to do that. I don't know if I would do that. I would just do substitution. If you took this and plugged it in for y right there, it just looks like this. 2x plus 1, that's what my y equals 4x minus 1. I suppose I would do this. Subtract 2x, that gives me 2x. I want my numbers on the other side, so I add 1. 2x equals 2, so x is going to equal 1. Same thing as that over there. Do you want me to graph it too? We don't have that kind of time. Oh yeah, we do. We do have escape room. Little boys versus girls, I think that'd be the best way.
What?
All
the
guys just
Let's really see who the smart people are in the class, huh?
We don't have time.
Gotta even it out a little maybe then.
Are you not saying that?
Yeah.
Precisely.
If you're a guy, you're smart.
Chase, what is that supposed to mean?
Everyone knows.
Problem number 12. Raise your hand if you got 12 correct. Oh,
Wait, we count.
wait.
I did.
Really? Warren, how did you not get this right?
Come on, Lauren.
Tell me how you tried it, first of all.
Well, I grabbed
Okay, I don't know if I would graph, ladies and gentlemen. I think I would use the slope formula.
Yeah, I got it right. I got it.
Well, you can get it right by graphing, but this way it's just mathematical, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you can pick any of these points. Let's do this. Here's my 0, 3, 0, 3, and 5, comma 11. You just plug those things in there. Please, please, please use parentheses. Y sub 2 is 11 minus 3 over 5 minus 0, which equals, looks like 8 over 5?
Yeah.
That's my slope. You could graph it, but again, your graphing would have to be very accurate. But you know it crosses at these 2 points, so those could have been the 2 points in each triangle. You should still get that number there. How about that? Change in y. Look at
Good
y
job, Mr.
changed
Hall.
by 8, x changed by 5.
Hello.
Oh boy.
That's all you have to do.
What?
So that's what I did, and I got it wrong.
You didn't do it right. Did you take your time?
Yeah. Wait, no, probably one.
How do you know which one is like x of 1 and like
Doesn't matter. Sophia asked a great question, which we've addressed before. She said, how do I know which one is x of 2 and x of y? It doesn't matter. This, you could call this, I called these 2 just because it was the second one, but you could call these 2's and this the ones. This could be your x sub 1, y sub 1. This could be your x sub 2, y sub 2. You'll still get the same answer. As long as you can't mix x sub 2 and make this y sub 1. Both points have to be the same, and the point have to be the same thing. Don't yawn in my class.
Hey,
Sophia.
love.
Problem number 13. Oh, we do have to get on our going here. What are we doing? We have the original price. It is a discount, so you subtract to get your final price. Wait, did I get this wrong?
I got it right. I did
Do
not.
I need to do this?
No.
Yes.
Yes, I know.
Yeah.
If Andrew got it right. I would use that.
The original price is 100%, Andrew. You're taking 25% off, so your final price is 75% of the original price. What would they give us? A boots that originally, the original cost was $95. What do I want? The new price. I don't care about the discount. I want my 100 over 75 equals 95 over what number?
Wait, how's it 100?
Whoa, wait, somebody had a question. How's what 100? The original price is always 100%.
No, for or like the
100 over 75, 95 over what number?
no on the right.
Because I don't need this middle one. Look, I'm not looking for this number, so I don't use this middle.
Yeah,
You're looking for the middle. You're looking for both of them. You're looking for
Oh, it does
discount
that. Oh, I'm
and
sorry. It does ask for the discount. I stand corrected. I could have done. I probably should have done the other one.
yeah, it's way easier because then you just add or subtract it.
No, let's just do it this way. So we have
Can't you just subtract the final from that?
Yeah.
So this way it's just confusing.
I'm sorry. Let's reduce this to 4 over 100 or 25 goes into both of those. 4 over 3. Oh, do we get some odd numbers?
The interest
Yeah.
So 3 times 95. By the way, what's 3 times 95? It's the same thing as 3 times 100 minus 15, right? 285? Is it 285? Caleb, what did you, or Andrew, what did you say it was?
23, 23.
What?
23, 23.
Oh, you have the opposite of what I got. 20 what?
Or 71.
71 point what? 71.35.
That's not the answer.
That's one of the answers. 71.25 is the final price, and how much off did you get? You got to take what? 20. Okay, Andrew, this is you.
What?
23.75. Good.
You can get it right all the time by this multiplying, right?
Yep, you do it your way. I don't care. I'm just showing you. After years and years of doing it your way, trying to have people do it that way, you can. If you're good that way, do it. Yes, you can multiply.
I can wait. So you get it right every time.
Shh, I can't guarantee you get it
No,
right
I
every
know,
time.
but
Doesn't go math.
this one's understandable.
What do you get?
This is it right here. 0.3. You just need to write this mathematically is greater than the sum, which means you're adding a number and 1.2. So 1.2 plus a number. That's it. Didn't say to solve it, just said to write it. I'm not going to spend your time on it. Oh, you probably want to do this. I'll even give it to you. Remember vertical lines? What's the slope of a vertical line? Undefined. How do you know that?
Because you told us.
Yeah, but how, if you could not remember that I told you that, think about what slope is. Slope is what? Rise over run. Or how wide? How tall over how wide? If you look at this straight line, how wide is a line? How wide is a line? It is 0. That is why it's undefined, because I'm trying to divide something by 0, which you cannot do. As opposed to, you should probably write this down, because maybe on tomorrow's test they'll give you a horizontal line. What is the slope of a horizontal line? No.
No solution.
No.
Infinite.
No.
Infinite.
No.
Zero.
Keep saying infinite, and I'll keep saying no. It is 0. How do you know that? Because again, go back to rise over run. How high is this line? It is 0 high. It could be anything. It could be 35 wide. You get 0. No matter what number you put on the bottom, you get 0. So you can divide 0 by a number. You can't divide a number by 0. So horizontal lines equal 0 slope. Vertical lines are undefined slope. Andrew, we're in the home stretch.
Almost there.
Wait, didn't you go by the racetrack? By the way to Arlington Heights?
Yeah.
Racetrack? What?
What racetrack? In Arlington, the Arlington Million.
Oh, yeah. The
That's where
horse.
the racetrack is right there. This one here, ladies and gentlemen, of means the multiply. Andrew, here's your multiplication. 1.25 times 15, I'm not gonna do that. I will do 17 because 17 you may or may not get right or wrong. It says to graph the relationship. What would be the cost of 7 pounds of tomatoes? Who got that one right?
Oh, wait, no, I didn't. Yeah, you said.
Well, I said, because they said use a graph to estimate, you're gonna have to do it with real graph paper, not what I'm doing here. I forgot. Alright, 3 pounds of tomatoes cost $2. This would be pounds. Wait, is this dollars? Sorry. Dollars, pounds? Let me look at it, make sure I get the right side of that. Yeah, this is pounds. Pounds on the bottom. Dollars here. How much would 0 pounds of tomatoes cost?
0.
0. So you got your starting point. Then you just need to graph this. 3 pounds, 1, 2, 3 pounds cost $1, $2.
Wait, how do you, oh,
It says 3 pounds cost $2. Draw your nice straight line, and then whatever they ask you for. They said 7 pounds, so you find line number 7. 1, 2, 3, 4, 5, 6, 7. Figure out where this line falls over here, and that would be the dollar amount. Again, yours because you're doing it on a piece of graph paper. Do you want me to do it on a little piece of graph paper? I don't know if I have that much time.
No, we're
Let's
good.
do it. Somebody said,
I said yes.
Chase, I appreciate that about you. Be a Chase. Don't just settle for nothing less.
Chase there.
Chase is a role model.
Chase is a
go
word.
Chase.
And
So
then,
I didn't know.
You did what?
A bar.
Okay.
Did it work? Right, yeah.
I'm all about barbers. Where's math? ladies and gentlemen? Which one do you want me to use? Grid small, grid medium, grid large?
Large. Grid large.
medium.
Large would have bigger.
Okay, let's do large.
It's kind of small.
Oh,
But
Can I go down to the bottom? Here you go. This is for Chase. Mine want to know. So we said this. Here's line 0. 0 pounds of potatoes cost $0. 3 pounds. 1, 2, 3 pounds cost how much? $2, right?
Dos.
So this is dollar number 1, dollar number 2. You need to get a straight line and connect the unfair dots. Oh boy,
oh.
I blame the board.
Yeah, I blame the board too. I blame the board.
I'm gonna do it over here and then come back.
That's smart. You really
How's that?
smart.
No, it's great.
Oh, it didn't work
you,
there.
you broke the system.
Zach, wait.
Oh. Pretty close.
Then just like, oh,
Don't worry. Just get rid of the lines. Don't.
Come on, board. Help us out.
Okay, now, like I said, you have to make absolutely sure you get right through the middle of whatever you're graphing in order that it's the most accurate it can be. And this is why we don't graph a lot of things, because it's not. So this is about as good as I'm gonna get.
It looks very beautiful.
And they said what? How many
7.
pounds? Chase. 4, 5, 6. Here's line number 7. And look where it crosses there. Definitely not $5. This is $5. This is $4. This would be about $4.50, a little higher than that.
$4.70.
$4.70, $4.80, whatever.
I got 450. I struggle with the graphing. It's alright if I don't show complete.
If you struggle with the graphing, it's gonna be hard to get a close answer.
Yeah, I got close without the graphing.
No, you can estimate, I'm not saying that that's not a possibility, I'm just saying.
Alright. So
if
should
you're
we
gonna do it-
try the graphing on it?
I would think that's a good idea.
Alright.
Trying is always good. Do I really have to do this one, 18?
No.
Say no, because you're just taking the highest number and subtracting the lowest, and the highest number subtracting the lowest. Oh, slope and y-intercept. Number 19, somebody? How about this? Solve for y. Why do we want to solve for y? Because slope-intercept form is solve for y, and that gives you both the slope and the intercept. Watch how easy, ladies and gentlemen. If you got this wrong, you should shun yourself. If I solve that for y, Jackson Roberts, what's the first thing I need to get rid of?
Oh wait, the 3.
3 in the x. I subtract the 3x to the other side, so now 4y equals a negative 3x plus 12, right? Agree with me,
I
please.
thought it was.
Oh yeah, got it.
Now to get y by itself, I have to divide by the number in front of y, which is 4. But I have to divide everything by 4. So y equals negative 3/4 x plus 3. Y-intercept, slope.
Oh.
Y-intercept,
That was way easier than I thought.
slope.
That's hard.
Problem number 20, let's finish that because we've got a boys versus girl challenge to do here.
Girls go first, then we guys.
No, ladies first.
Take a look, see children. Oh, I probably should have done this just as a cards. We're talking cards and dollars, right?
Yes.
If 2 cards cost
$7.
$7 and 3 cards cost $10, it deals with slope again. What's the difference between 3 and 2? If you subtract those, you get 1, right?
Yes.
There's only 1 card difference. Well, if you just put 1 card with it, and this went up how much? $3. That means for every card you just keep adding $3 because that's how much each card would cost.
Oh.
But you're starting with 2 cards costing $7. So for 5 cards, 4 cards would cost $13 and 5 cards would cost $16. You're just adding. That's really what that whole slope ordeal is telling you. Every card you're just adding $3. If you find out how much each card is, but it's not, you can't just multiply 4 times 3 to get this. It's starting with that one. Every card from there on costs $3.
Thank you.